Hello everyone, welcome back to my new video. Today my topic is data structure. So what is data structure? Data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. Depending on your requirement and project, it is important to choose the right data structure for your project. For example, if you want to store data sequentially in the memory, then you can go for the array data structure. This is the array data structure representation where each and every elements are located in the contiguous memory locations. Now, types of data structure. Basically, data structures are divided into two categories. First is linear data structures, which includes array data structure, stack data structure, queue data structure, and linked list data structure. And second one is non-linear data structure. It includes tree and graph data structure. Now what is linear data structure? In linear data structures, the elements are arranged in sequence one after the other. Since elements are arranged in particular order, they are easy to implement. However, when the complexity of the program increases, the linear data structures might not be the best choice because of operational complexities. Popular linear data structures are array data structure, stack, queue, and linked list data structures. Now what is array data structure? In an array, elements in memory are arranged in contiguous memory. All the elements of an array are of the same type, and the type of elements that can be stored in the form of arrays is determined by the programming language. An array with each element represented by an index 0, 1, 2, 3, 4 and so on. Now stack data structure. In stack data structure, elements are stored in the LIFO, that is last in first out principle. The last element stored in a stack will be removed first. It works just like a pile of plates where the last plate kept on the pile will be removed first. In a stack, operations can be performed only from one end. Queue data structure. Unlike stack, the queue data structures works in the FIFO principle where first element stored in the queue will be removed first. Here FIFO means first in first out. It works just like a queue of people in the ticket counter where first person on the queue will get the ticket first. In a queue, addition and removal were performed from the separate ends. Linked list data structure. In linked list data structure, data elements are connected through a series of nodes, and each node contains the data items and address to the next node. There are three types of linked list: singly, doubly, and circular linked list. Now is non-linear data structure. Unlike linear data structures, elements in non-linear data structures are not in any sequence. Instead, they are arranged in a hierarchical manner where one element will be connected to one or more elements. Non-linear data structures are further divided into graph and tree based data structures. Now, graph data structure. In graph data structure, each node is called vertex and each vertex is connected to the other vertices through edges. Popular graph based data structures are spanning tree and minimum spanning tree, strongly connected components, adjacency matrix, and adjacency list. Now, tree data structures. Similar to a graph, a tree is also a collection of vertices and edges. However, in tree data structure, there can only be one edges between two vertices. Popular tree-based data structures are binary tree, binary search tree, AVL tree, B tree, B plus tree, and red-black tree. Now, the difference between linear and non-linear data structure. In linear data structure, the items are arranged in sequential order, one after the other. Whereas, in non-linear data structures, the data items are arranged in non-sequential order, i.e. in hierarchical manner. In linear data structures, all the items are present on the single layer, and in non-linear data structures, the items are present at different layers. Linear data structures can be traversed on a single run. That is, if we start from the first element, we can traverse all the elements sequentially in a single pass. Whereas, non-linear data structure requires multiple runs. That is, if we start from the first element, it might not be possible to traverse all the elements in a single pass. Now, in linear data structure, the memory utilization is not efficient, whereas in non-linear data structures, different structures utilize memory in different efficient ways depending on the need. The time complexity increases with the data size, whereas in non-linear data structure, time complexity remains the same. Examples of linear data structures are arrays, stack, queues, and examples of non-linear data structures are tree, graph, map, etc.